So we will talk about context and about debugging in Haskell. But before we do that, I want to talk a little bit about the development, about how we are developing things in Haskell. So most of you are doing it, but some of you are not yet. And I would like to stress that you should do it with stack, okay? So if you go to I go to projects, yeah, and then I am in my folder, which is dedicated to PROG2006, and I want to start a new project in Haskell. I would say stack new, and then specify a folder name, and it will generate some skeleton for me, right? So let's do a first project. Let's call it, I don't know, first is not a very creative name. Let's call it Berlin. Okay, we will use names for cities, and then we will have a project generated. And the way Stack generates the projects, so if I go to JC app and check which Stack version I'm using, so I'm using a specific Stack version, and the specific Stack version will generate specific template for the project, right? It will use a specific version of Haskell compiler and so on and so forth, right? So then you can also observe that I have installed my default compiler is 9.10.1, but I also have installed 9.8.4. Why? Why do I install 9.8.4? Because 9.8.4 is the default compiler the projects are generated with this stack version. So this stack wires you up in the template with this version of the compiler. So because I have it installed, then if I say, let me quit. So if I say now CD, what do we call it? Berlin. If I go CD Berlin and I say stack run, it will try to compile it with the compiler version, which is 9.8.4. And then it executes it. Okay, so how do I know that this is the compiler that it's like it says here, right? You see? It told me it's using 9.8.4, right? Okay, so far so good, no problems with that. I opened the project in code, and we can look at the structure. So the structure is, you can see it, or is it too small? So there is a bunch of files generated, and the interesting ones are source, which is the main module for where the main logic goes of your program, and main, which is the main module, which is the entry point to your application. So the main function is the one which is like, it's like in C or any other languages, like it's the entry point, right? And then you calling stuff in here, which you have declared in your lib. So as you can see, we are importing the lib, and inside the lib, we have exported some function, right? So if I rename it, if I say I have a hello function, and then I rename it to hello, then I'm putting string out, hello from Haskell. All right, and then if I rerun it, again, it will use the compiler, and now it complains, okay, main is trying to call some func, but we don't have some func. So I go to main and I change it to hello. And that's the kind of preferred way of building your application, such that you keep in main everything that has to do with I/O, everything that you sort of doing like I/O, and then you keep your lib kind of using pure functions, that you can test and you can write doc tests for. And then you export the ones that you need to use in main, or the ones that you want to use in GHCI as module like exports, right? So this is like a template which is generated for you. Inside source, you have one module called lib, and then you define your functions here. And then in main, you call one of them as the entry point to do whatever you need to do. So for lab 6, we already have it. So if I go to lab 6, labs, lab 006, I already pre-generated this such that we have the lib, and it says, okay, sorry, that is too. All right, so lab 6 was generated with stack new lab 6, and that's what it is. And then you will notice that VS Code complains. It says, okay, the support for 984 for language server is not there yet, okay? What is this all about? Well, the IDE needs to talk to a language server to understand all the symbols and what is what, right, in the language. So it can do syntax highlighting for you, and it can suggest functions for you, right? And it uses what's called a language server. And the language server in Haskell is called Haskell Language Server, HLS. And for 984, it does not exist yet, right? So for lab 6, like when you try to load this project, it complains that, okay, you don't have a language server for that version, so you will not have a nice language support, which sucks. So how we can fix it? We have to go to stack, and then in stack, instead of using this snapshot with this URL, which is the long-term support resolver for the package manager with this long URL, but effectively it is LTS 2310. You want to comment that out. I will do it for lab 6. And we want to use something else. We will use this one, and we will use the latest snapshot 90 version, which is 25.03.07. Why? Okay, it's a little bit complicated. So let's go back to our GHUP2E. And here we can see that we have, I have installed Haskell language server, the latest recommended. Okay, that's fine. But the language server is not for all the versions that we have, right? So as you can see here, 984, it is not HLS powered. Sucks, right? So Stack is picking the only version of the Haskell which does not have HLS support yet, right? But the latest one, the latest 9.10.1 is not the latest one. The latest one is 9.12.1, which also does not have HLS support, but 9.10.1 has. So if you say, I want this one to be my main one, so you set it to be your main compiler, such that if you go, sorry, if I go GHC version, it's using, my default version is 9.10.1, great. So then, sorry, here. So then what we want to do is we want to tell the project which Stack generated for us to use 9.10.1 instead of 9.8.4. And we do that by modifying this resolver, okay? How do I know which one to use? Well, if you go to this URL, yeah, maybe don't go to the URL, maybe just Google it. So Haskell LTS resolver. And then you get to the, not this page. Uh, uh, so 2311 is the one which, yeah, so yeah, it is that page. So it's the first page which Google gives you. And then you can go to the LTS and it says the latest resolver is 2311, right? And this is what Stack is using because if you observe this URL, it says 20, okay, actually it says 2310. So it's using not the very latest one, it's using one version lower. But this one, unfortunately, is using the compiler version 984, and we don't want that. So we can go to snapshots and we can look for the snapshot which is using 9.10.1, right? Which is the version that we have. And the nightly version is like one typical example. If you want to go into the latest long-term supported version, it's 2311 from 3 days ago, but it is still using 984. And 984 does not have the Haskell language support. So by picking this one, we will be using this compiler and we will have the language support. So if I change this in snapshots to nightly 250307, which is today 0307, I will be bound to this compiler and then everything will be fine. So if I save it and I quit my code, oh, come on, close yourself. I have some UI issues. Okay. Then if I go to my terminal and I go to lab 6 and say stack run, it will rebuild it because now it's rebuilding it with the new compiler. So it's using GHC 9.10.1, right? The project does not really work because you have to fill in the things. But if I open the project now in code, I will not have this warning anymore. And the project will say, yeah, it's fine. It's installing the language server link. It kind of checks all the symbols and it does not complain about the server missing. And you get those correct, annotations and code completion for your code, right? I know it is a little bit fast and it's a little bit like too much information at once, but you can like rewatch the video and then follow the steps to get your stack generating what you want and then updating inside the stack YAML this snapshot thing, right? That's all you need to do. Is there any questions about this? Yeah. Unfortunately, it's a manual job you have to do every time. Yeah. So once the stack will update to the latest long-term supported resolver, it will be 2311, but it is still using the 984 compiler, right? And then you have to kind of fix which compiler you want to do. Why are we doing all this? Because the version of the compiler and the version of standard libraries, they have to match such that all your dependencies get correctly resolved. Otherwise, you get conflicts. You say, this version depends on this one, but you don't have it yet because it's newer than this one, and you get this kind of dependency mess, right? So the resolver is like a pre-built dependency resolver, which knows what depends on what and on which version, such that it's always doing that job for you perfectly. All right, so that's one thing. Any questions about, so we basically have to do the same change here, right? So I generated this Berlin project. The snapshot is the default one, which is the 2310. We commenting that out. We going here, uncommenting this. No, I'm not uncommenting this one. You could force a particular compiler. So we could say here 9.10.1, and instead of choosing the resolver, we would choose the compiler. But that is a very, I don't recommend doing that, okay? Because you want your resolver to match the compiler. And you do that by choosing a proper compiler. So you can choose it by this URL, or you can choose it by the name or long-term supported version. So if we could like, sorry, if we set here 2311, we would be using the latest one, but the latest one is still using 984. So we don't want normally you want to use the LTS version. Like that's like if you can, or you always should use LTS. But if the LTS version is using a compiler without the language support, then we have to do some hacking. So our hacking is that we're gonna use nightly. And then we save it, and then we stick to it. So then if I go to Berlin, and I build it now, so I say stack run, then it will use the 9.10.1, and then I have the language support. And it prints this hello from Haskell at the end. So if I say stack run again, it does not need to compile it, so it just prints the output, right? All right, so that's what you do when you are using a stack for generating a template for you and for running it. Of course, you can say stack test, and it will kind of run tests for you if you have any, and it will run the doc tests as well. And in lab 4, so if we go lab 6, again, I go there. You will observe that in tests, there is a spec file, and it kind of annotates, it injects that everything in the source folder and app main should be doc tested, and it runs the doc tests for you. So in lab 6, if you say stack test, it will automatically run all the doc tests for you, right? And for this to work, you have to do this import and do this doc test invocation in main for the spec in test spec, and you need to add it in the packages. So in packages, at the end, where you have tests, you have to include doc test. So for dependencies, you have lab 06, which is the main module for testing, and then you have to add this dependency, which is doc test. If you want to use hspec, then you would also add hspec, right? You would also do this if you're writing some unit testing for your project. All right. So that was a very quick rundown of the fiddling with the compiler version and of the so I have to update because I changed the version of the resolver. So I have to update my files. And I have stack YAML lock and stack YAML, which I modified. So I will quit and say git commit updating the compiler and resolver versions. Okay, and then git push. So now the lab 6 is updated. You may notice that I use git add interactive. If you don't know about it, it's like an interactive way of adding files to the commit set. So before you commit, you have to pick which files to be included in the commit, right? And git add interactive allows you to do that automatically. So you can check what files you have now to be updated, and then you can, with 2, you can update files, or with 4, you can add new files. So I've added this Berlin thing, so I can now pick which files I want to include in the commit by using the numbers. So it's kind of a convenient way for interacting with Git without typing a lot of file names. You can sort of, pick what you really want to commit. All right, so that was most of what I wanted to talk about Stack, but there is one more thing. So if you go to lectures, so in the project file, the main project for the course, if you go lectures, you will see that there are two folders. There is a Haskell folder and Golang folder, and of course Solidity folder with some examples. So all of those are kind of examples. So if I go to let's go to Golang first. So in Golang, we have one folder called Hello Chuck, and it's a simple REST API call to a server to get a JSON back and then to extract one particular value out of this JSON and then print it on the screen, right? So if I go to this URL, let me, oh, come on. If I go to this URL without the, I will get a JSON back. And the JSON back has a couple of fields. It has a category field with an array of strings. It has a created at with a date. It has an icon URL and so on and so forth. And it also has a value, right? And the value is the joke. So we want to extract this joke and print it on the screen, right? So how we doing it? We have to declare a joke struct which follows this structure of our JSON, right? So we kind of saying, okay, we have this category, icon URL, ID URL, and the value. And the value is like, we call it with capital V because in Golang, we have to make public things with capital letters, but in the JSON, it is small v. So we have to tell the struct that in JSON, it's a small v, right? The name for the field in JSON is not exactly the same as the name in our struct. And then what we do, we prepare a new request, a new GET request with this URL, which is here. And then something can go wrong. Then we create a client to open the connection to the server and make the request. Again, some things can go wrong. And then we say, okay, if something goes wrong and we kind of have an exception of some sort, I want to close the connection, like because we are currently having the HTTP connection open for reading the body. So we are deferring it, right? You know the defer keyword in Golang? Yeah. So then we have to get the joke. And we're getting the joke by JSON decoder, right? So we're decoding the body of the response into our struct. So you're doing it with Christopher, you're doing it in the cloud course. We kind of making the requests and writing the servers. And we are printing the joke at the end, right? So if I go to Golang, go to hello Chuck, and I say go run. Let me clear. Let's say go run. Then it compiles and we get the joke, right? Right. They are a little bit dry, but we doing it as an example, of course. So then if you go to Haskell, so we go out of Golang and we go to Haskell, we basically have the same. So in Haskell, we have a project which is doing exactly the same. So it creates a joke structure for parsing. And then it has the same URL for getting the joke. And then we getting the joke and then getting the value out of the response body and printing it. So in main, we say print get joke, and get joke gives a string back, and put string line kind of prints the string to the screen. So you can see that the get joke gives us the string of the joke, but within the IO monad. And then in main, we getting the joke in the IO monad, and then we binding it to put string. Put string takes a string, not a string in an IO monad. So we have to use this bind operator to extract the actual string of the joke and then be able to print it to the screen. And it's the same code as doing the do notation, right? So the do notation is exactly the same as this, and it's like a syntactic sugar for achieving the same thing, but using the do notation. So we're getting the joke, and then the joke is a normal string, and then we're saying put string and putting that string here. In lab 5 or 6, you will get a bonus points if you avoid using the do notation, right? If you follow the operators. And the reason is for you to kind of understand the notation better by like playing with it. And then in here, there is a lot of magic that happens in this single line because all the parsing and all the extraction is kind of condensed into a single line. But to get this single line working, we have to do this instance. We have to prepare this data structure, and we have to declare that we are deriving generics because in here we are saying like deriving generics and show, right? So I don't want to dive into that code yet because there is a lot of machinery that we haven't talked about yet, but I'm using this code to explain two things. One thing is that I changed the snapshot also to use the latest compiler, the 9.10.1. And then I also, in package YAML, I have to tell the compiler that my project depends on those three libraries. The first one is a JSON parsing library, like one of the best in Haskell. And then the two other ones are for accessing the HTTP, for building the request and getting the response, right? So you have to include the dependencies in the package YAML. And for this particular example, it is done. But if you were to use that API yourself, you would have to do this in the package YAML. So stack YAML is for stack to control the compiler pipeline. And then package YAML is for our project, like what the project name is and who is the owner and blah, blah, blah. And then what are the dependencies? The normal dependencies, and at the bottom, the dependencies for tests. Because I'm not doing any tests, I don't include doc test or hspec here. But in your projects, if you are doing tests, you have to include that here. Any questions about the Chuck API example? So then again, if we say stack run, it will build. Because I didn't change anything, it does not need to build. So if you copy those two projects, two things will kind of occur to you. So one thing will occur that compiling the Haskell takes forever, right? It really takes forever. Like you have to build all those three libraries. Those three libraries are quite big and they have their own dependencies. So there is a total list of over 100 dependencies that needs to be compiled, and it takes a long time. If you do that project in Golang, it's almost instantaneous compilation, right? And that's a very big strength of Golang, that it has a really fast compilation cycle, but also it has a very big standard library such that you don't depend on external dependencies for a simple HTTP request, right? So there are some obvious strengths. The drawbacks are that in Golang, you're doing kind of a lot of if statements, and the code is very kind of spread over the page. And in here, this is very similar to Golang. And then the magic happens kind of for you because you're doing this declaration that this joke has ability to be able to be extracted from JSON, and it's auto-generated for you, right? And then like it just happens that you have the value function because you have the value identifier in your joke, and you can get this value automatically. So I'm not doing any checks here for errors, and I'm not doing any kind of manual coding. it's all happened by the framework, by the machinery that the libraries give me. And there is a little bit of a discussion on this operator. We will come back to this operator today in a second. And it kind of talks about like how it is used and why, and what else could we use? We could use bind also, or we could use do notation, right? So what we could do is we could use do notation to express that we're getting the string out of the body. But with those operators, it is sort of more idiomatic. And then there is a note about error handling that we are not doing any error handling here. The project works, right? So if I say stack run, it works and there are no errors. But if there were errors, if my network was not working, the program would just panic, right? And programming with panics is frowned upon. We will talk about it later when we go to Rust. But we normally try to avoid programming with panics built in, right? You want to handle your errors yourself. But to handle your errors yourself, you cannot use this high-level API to HTTP. You have to use lower-level API such that you can catch errors and handle them yourself, right? So then we would have to use slightly different API. And this is why we are kind of, for example, having this imports which are not being used, but I can discuss it later of how we're handling the low-level API once you get familiar with the fundamentals, right? So we will talk about it later a little bit more. All right, that was really fast, but I kind of highlight that you have those things available in the examples, and then you can try things out. So I will stop here for a moment.